Hello students, today we will study about the factor theorem. This is the topic of standard 9 chapter number 2 polynomials. So in previous class we have studied about the remainder theorem, and that theorem is related to the division of two polynomials. Similarly, factor theorem is also related to division of the two polynomials. So first of all, let us understand this theorem by taking digits. Suppose we want to divide 51 by 3. So by dividing 51 by 3, what you will get? 17, 3 17s are 51. And the result we get is equals to 0. So our remainder is equals to 0. So from this division, we can say that 3 is a factor of 51. That means this is the dividend, this is the divisor. So whenever we divide with the divisor and if remainder becomes 0, then we can say that our divisor is a factor of the dividend. Okay? So this same thing now we will study for the polynomials. Let us take one example. The polynomial p of x is equals to x cube plus 3x square plus 5x plus 6. This is our dividend polynomial. And we want to divide this polynomial with g of x is equals to x plus 2. So this x plus 2 is our now divisor polynomial. So now we do not need to divide like this because we have a remainder theorem. By remainder theorem we can easily find out the remainder, right? By remainder theorem we can easily find out what will be the remainder if we divide this p of x with g of x. And to do that, first step we have to do is to find the 0 of this divisor polynomial. So to find the 0, we have to take g of x is equals to 0, x plus 2 is equals to 0. Therefore the value of x we get is equals to minus 2. Now using the remainder theorem, we can get the remainder by putting x is equals to minus 2 in the p of x polynomial. So by putting x is equals to minus 2, we will get minus 2 whole cube plus 3 minus 2 whole square plus 5 minus 2 plus 6. And the result we get is cube of minus 2 is minus 8, minus 2 square is plus 4, 4 3s are 12. So here we get plus 12. 5 2s are 10, plus minus minus, and plus 6 remains as it is. So here minus 8 minus 10 minus 18 plus 12 plus 6 plus 18 plus 18 minus 18 is equals to 0. So what we get the remainder? P of 2, P of minus 2. The remainder P of minus 2 is equals to 0. Right? So now by comparing this one, if here we get the remainder 0, we can say that this 3 is a factor of this 51. In the same way, as the remainder is 0, we can say that g of x is a factor of this polynomial p of x. Or we can say that this g of x divisor polynomial is a factor of this dividend polynomial. Right? So in this way, we can find out the factor of any polynomial. If by dividing we get the remainder 0, then the divisor polynomial is a factor. Or if we do not get the remainder is equals to 0, then we can say that the divisor polynomial is not a factor of dividend polynomial. Okay? Okay, so let us see what is the statement of the factor theorem. The statement is, if p of x is a polynomial of degree n greater than or equal to 1 and a is any real number, then first thing is x minus a is a factor of p of x if p of a is equals to 0. And second thing is p of a is equals to 0 if x minus a is a factor of p of x. So both these result 1 and 2 are similar, but they are stated as like this. Okay. So meaning of both the statement is true. So let us understand again this thing by taking an example. But first of all, see here, what we have given is p of x is a polynomial of degree n greater than or equal to 1. That means the polynomial that we have to take as an dividend polynomial, it must have a degree either 1 or greater more than 1. And a is any real number. A is real number, that means a may be a rational number or irrational number, any number. Then x minus a is a factor of p of x. If p of a is equals to 0, this means if we get the remainder is equals to 0, then x minus a become a factor of p of x. So let's suppose our p of x is equals to x cube minus 4x square plus x plus 6, and g of x is equals to x minus 3. So this p of x is our dividend polynomial, g of x is our divisor polynomial. Okay, so to find the 0, first of all we have to take g of x is equals to 0. So g of x means x minus 3 is equals to 0. Therefore the value of x we get is equals to 3. Now to find the remainder, by using the remainder theorem, we can put x is equals to 3 in this polynomial. So p of 3 is equals to 3 cube minus 4 into 3 square plus 3 plus 6. Right? So here we get 3 cube is 27 minus 3 square is 9 and 9 for the 36. 6 plus 3 is 9. So now 27 plus 9 is minus plus 36 and minus 36. Total is equals to 0. So our remainder p of 3 is equals to 0, and according to the factor theorem, if p of a is equals to 0, so here p of 3 is equals to 0, so x minus a is a factor of p of x. That means x minus 3 is a factor of this polynomial. Instead of a, here we have 3. So here x minus a is a factor of p of x. Here x minus 3 is a factor of p of x. Why? Because remainder is equals to 0. So we can say that g of x is a factor of the given polynomial. So in this way, we can check any polynomial as a factor of the another polynomial or not. So this is all about the factor theorem. Okay. Okay, so let us understand some of the questions based on the factor theorem. So the question is, find the value of k if x minus 1 is a factor of, first question is p of x is equals to 2x square plus kx plus root 2. Now what we have given is, this is a given polynomial and x minus 1 is a factor of this given polynomial, and we have to find out the value of k. So we have given one thing, that x minus 1 is a factor of the given polynomial. So we can take remainder as a 0. Yes, because this is a factor. So remainder is obviously 0. So first of all, to find out the remainder, what we used to do is find out the 0 of this polynomial. So to find out the 0 of this polynomial, take x minus 1 is equals to 0. Therefore, the value of x we get is equals to 1. So now, according to the remainder theorem, how to find out the remainder? By putting the value of x in the given polynomial. So now this one p of 1 is our remainder and it is equals to 0 because x minus 1 is a factor. So according to the factor theorem, p of 1 remainder is equals to 0. Now put the value of 1 instead of x. So here we will get 2 into 1 square plus k into 1 plus root 2 is equals to 0. Now simplifying, 1 square is 1 and 2 ones are 2 plus k ones are k. and plus root 2 as it is equals to 0. Now by taking this 2 and root 2 to the right hand side, both will become minus. So the value of k we'll get here is k is equals to minus in the bracket 2 plus root 2. Okay, so in this way, by using the factor theorem and remainder theorem, we can find out the value of k in this type of sum. Let us study one another sum. In this question also, x minus 1 is a factor of this given polynomial. So the value of x we get is equals to 1, right? Like we have done here. So now p of 1 is also 0 according to the factor theorem. So what is the p of 1 for this polynomial is k 1 square minus root 2 into 1 plus 1 is equals to 0. So 1 square is 1, k 1 is k. Root 2 into 1 is root 2 plus 1 is equals to 0. Now by taking this minus root 2 and plus 1 to the right hand side, we will get the value of k. Therefore, k is equals to root 2 becomes plus 1 becomes minus 1. So the value of k we get here is equals to root 2 minus 1. Okay. So in this way, by using the factor theorem, we can solve this type of questions. Okay. So this is all about this lecture. Okay. Thank you.